Welcome back. We will see like how we can test the real world projects using Golang test cases. Okay, we'll talk about strategies for testing large projects. Basically, we need to have a test organization, meaning that no, the test cases directory we need to follow the structure. This we already discussed about it, and also naming conventions and category of the test cases. Locally, like logically how we can make it subdirectories as well, and also test suites. We already spoke about this, like grouping of the related test cases together. It will help us to run the all the module feature wise the test cases. If there any test cases are failure, we can go and check that particular module or feature. And parallel testing, this also we already spoke and we have a hands on. So to minimize the test running time, basically we can run the test in a parallel. And also mocking and dependency injection. These things also we had a hands-on coding. For large projects, yes, we need to do this. So sometimes we are not able to cover the all the test cases with the code. We need to mock some testing. So those things we need to use the interfaces for the dependency injection. Now, this also we had some hands-on actually in the previous sessions. Continuous integration, actually integrating testing into your CI/CD pipeline. Basically, automated testing and continuous integration, making sure that there is no breaking anything in existing code or existing large codes. Code coverage. This is also one of the important area. This also we discussed in our previous sessions using the Go test tool, cover tool, which actually gives the which part of the code actually covered by executing the test cases and which is not. So whatever not covered code, actually we can improve the test cases by writing extra test cases. And refactor for the testability. Yes, you can keep refactoring the code whenever you feel like the things are um, growing basically. If you refactor it, it is more easy for you to write the test cases for the functions. And we'll see legacy code how we can test. Legacy code basically what we can do is we can characterize this testing. Basically you need to start capturing the existing behavior of the code by writing tests and reproduce its current behavior, and it provides the safety for the next changes basically. And gradual refactoring, incremental refactoring legacy code to make more testable. And also unit tests, whatever you created refactor the code, you can newly create the test cases for that as well to improve the code coverage. And component isolation, it is it is focusing on not isolating the components or modules for testing. By testing individual components or interfaces, you can avoid extensive integration testing later point of integration testing. So for legacy code that heavily relies on the external dependencies, integration tests can be useful. So however, you can focus converting them into the unit test cases whenever possible. So case studies and best practices. For example, if you see right, Netflix is also no robust microservice architecture and uses like tools like Spinnaker and Prana for testing in the production. Okay, and A/B testing. Google also uses some kind of testing unit testing tools to make like end-to-end the massive code base is the up to the mark. Cockroach DB also uses some testing kind of things. And best practices is like use the test driven development, write the test cases before implementing code. This approach encourages well tested code from the start and helps the drive the design for your application. Automate testing, invest time on automate testing, ensure the consistency, reliability, and also this will help us for CI/CD pipeline. Keep tests simple and isolated. Write small and focus a test to verify the specific behavior. And regularly, as we discuss, right, review and refactor the tests. Measure and monitor the code coverage. This also we discuss with hands-on. And also use the test double. This also we discuss like stubbing or mocking the test cases. to make sure like we are able to cover the more code basically. Okay. Test data also should be like isolated. Okay, this should not interface with each other. Isolate test data is prevent unexpected side effects. Okay, and also it is important to know document and communicate clearly about what tests are included, and and also other team members should understand what exactly you are writing here. That's about the real time real world projects and its benefits as part of this session.